So let's talk about current events in space. Okay. So we're going to talk a heck of a lot about this spacecraft. It is called the Starship. Well, we're going to talk about it a lot. Last week they had their last test. So this is the Starship, super heavy. We'll talk about it a bunch. They had their last test last week, and it was pretty cool. Okay, pretty dang cool. Kind of. Okay. So let's check this out. Oh my gosh, dude, my computer is trying to die for real. Like, it cannot handle life.
You might do this now.
So this is stage 2.
Minus 5 minutes.
So this is stage 2 of the Starship configuration.
Wait, is this the rocket that's supposed to bring us around the planet?
No.
Yes. So this is the spacecraft that is designed to take people from place to place on Earth in under an hour. It's also designed to take people to the Moon, Mars, transport huge amounts of cargo into low Earth and medium Earth orbit. It's going to be a very, very functional spacecraft.
Did they make the landing this time?
So let's see how liftoff goes. What? Okay. So let's see how liftoff goes. 6, 5, 4, 3, 2, 1, 0. Okay.
That smells wonderful.
It's really slow, but they designed it that way. They're just wanting to do some basic tests here.
Is this CGI?
This is real life.
Why does it look like that?
Why does it look like what?
The beam coming out of it.
The beam coming out of it? This looks like a laser. Yeah.
This looks like CGI.
That is an extremely hot exhaust gases of liquid methane and liquid oxygen combining together at like 400 atmospheres of pressure, which is just stupid amounts of pressure. So here's when they get up to apogee. We know what apogee is, right? The farthest point in a flight from the surface. And this is where they perform the flip, so it starts falling like a skydiver.
Why is it shaking? Why is the cameraman having?
Why is this? Well, because it's trying to focus very, very far away, because this is 10 kilometers up, and because there's wind. There's this thing called atmospheric movement. We call it wind. Where is it falling from?
And where is it filming from?
Oh, so they have different camera stations all around the launch and landing pad. Okay, so it's falling, 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 fall, fall, fall. Okay. Remember, they relight the engines and then perform a flip maneuver. This camera angle right about now, yeah, is so cool.
That is a cool camera.
Okay,
Like CGI.
they relight all 3 engines.
Oh my gosh. That doesn't look real. Yeah, this looks like CGI.
So that fire is not supposed to be happening. It's on the side, but the engines.
Landed.
I feel like it. Oh, you're so.
Little hot, but it did.
Okay, it successfully landed.
That's just backline, dude.
So pretty cool. It's got a little bit of a lean going on, and there is a fire. They try and put the fire out. It does not fall over. It does blow up.
What?
How did it blow up?
We don't know yet.
This sucks, man. This is too many.
So I finally found the perfect T-shirt for my guy.
No, he's.
I bought this the XL. She says it's big baggy, and now he's turned. Anyway.
But that's better than last time.
Okay, so here's what happened. They did the launch and everything. They landed it. It was beautiful. And then 8 minutes after it landed, 8 minutes after it landed, it does. So that was the landing. And then we're going to skip the 8 minutes in between.
Oh, thanks, Dad. You're amazing.
Yeah, this pelican's like, whoa, what is going on over there?
I'm cool. Look at these like.
Okay, obviously this is in slow motion.
Why did it pump so high?
It's very Michael Bay-esque.
Because of, like,
This whole thing looks like a movie.
Okay, but this, so what I want you to watch specifically is, oh, I love these. These are called COPVs. They're carbon overwrapped pressure vessels. You can see they fly off. They have highly pressurized nitrogen. Oh, watch this. Okay, so this is right before the explosion. I want you to watch right here. The acceleration is so fast that the nose cone crumples. And it's really fascinating. So this explosion launches it up off of the ground. So what? Boom! That's my favorite. So watch again. Watch how it crumples right there. Boom! Okay. The fairing completely collapsed because of the weight of the acceleration.
It was just too hot, bro.
There were people trying to put out the fire.
There were no people near this. No.
Oh, how just ran back.
Those hoses are all autonomous. There was nobody around this. No one was injured.
Well, I mean, they landed it successfully.
They landed it successfully, but they were trying to get rid of all the fuel and oxidizer. They were venting it off of the spacecraft, and they were trying to put out that fire. They put the fire out around the spacecraft, but underneath in the engine bay, in the engine skirt, that fire was still going. And more than likely what happened is there was a leak, and you got the combinations of the fuel with the oxidizer, and it went kablowy. Okay? So
What's causing the engines to not start?
the engines did start.
I
Oh,
mean, they did, but then they just died out.
so you can shut off the. So what do you mean, like
When
with the leak?
flipped and landed.
So they went out on purpose. So they lit all three of them to land, and then after it completes the flip maneuver, they don't want all three engines going at the same time to bring it down to land, because all three engines would produce too much thrust. They land on just one because it creates so much thrust, it's able to just slowly lower it down. If you leave more than one lit, then it starts going back in. Philip?
Do you have any idea as to why the fire started on its way down?
My guess is what happened is that when they shut down one of the engines, one of the pre-burners, which is where they get the turbo pumps to go, was venting out, and that venting kept a flame going off to the side. So yeah, repeat.
That is probably one of the coolest rocket explosions.
Yeah, it's a very cool rocket explosion. Okay, other news. Our favorite little rocket company that could, the ones that make the Electron Rocket Lab, have just announced that they are now building a larger rocket named Neutron. So this is Electron. It's just a little boy.
That's an apple pen, don't I?
That's an apple pen, an eye pen. The Electron is just a little boy. The Neutron is designed to be a medium class launch vehicle. They are also planning on making it human rated. They are planning on making a capsule that can carry humans on this thing.
The next one will be the Proton.
What was the purpose of it?
So the Proton already exists, but it's not from Rocket Lab. It's from the Russian space program. So there's been a whole bunch of jokes about the Atom rocket.
What's special about the Neutron?
The Neutron, it's larger. It's also reusable.
And they can have people.
No.
That car looks so stupid. I would crash that one.
Dude, imagine driving to
What's
space.
this gas mileage? Because it doesn't seem aerodynamic.
Where is it? No. There's a subreddit called SpaceX Master Race, and yes, I am a member of the SpaceX Master Race subreddit. But anyway, there's a whole bunch of jokes that they have the core stage of a proton with 2 neutrons on, or 2 electrons as the boosters, and then a neutron upper stage. They're like, behold the Atom launch vehicle. Anyway, so pretty cool. The Neutron, I'm really excited about it. The way that they announced it, is Peter Beck, who's the CEO, sat at this table, and then they zoomed out, and you just assumed he was in this cool, like, black, futuristic black and silver room. And then they zoom out, and you realize that it's a payload fairing for a large rocket. Yeah. So it's pretty cool. Also in this video, he literally eats a hat. So there's that.
He eats a hat?
He eats a hat. Because he said that if Rocket Lab ever tried to recover and reuse an electron, that he would eat his hat because it wasn't in the plans. Well, they came up with a way to reuse and recover the electron, and so he had to eat his hat. So he cut his hat into different pieces, blended it up in a blender, and then just like grabbed some tweezers and ate a few pieces. Anyway, pretty fascinating. That's disgusting. All right.
I think it was a leather.
It was not leather. It was
a jerky hat.
I believe it was a polyester cotton mix. Your body just doesn't digest it. It's not that big of a deal. It just goes through you. Just fiber. Same thing that happens to you if you like eat grass. Okay. Yeah, you're welcome. So that's what's been going on. Okay. So the KSB stuff assignment. There's been some problems with me wanting to make that assignment. The reason why is because the online students need a copy of Kerbal. So here's the thing. You can work on your Kerbal Space Program stuff, but it's not going to be due for a few weeks because I want the online students to have an opportunity to come and get a totally legal copy of Kerbal Space Program. The school doesn't know. Elijah? That's a great question. Today. Okay, so
All right, I need to know space.
So everybody, stop playing Kerbal. Oh man, but I want to play Kerbal, says everybody. Once you have it put on your computer and stuff, then it's not that big of a deal. Who? Okay, good. Oh, wait. and then you go here. So you already have a shortcut.
Well, no, I think somebody went in there and made a shortcut with that shortcut.
There you go. Now you're done.
Wait, can I?
Company generates bullshit.
Yeah, you wanna
Yeah, we're gonna take some notes here. Yeah, that's fine. Okay. This should work just fine. All right. I believe the camera needs that now. Philip, will you take it to camera, please? Were you able to log in, camera? Yeah. Okay. Elijah, help camera. Okay. I'm sure that that's a very interesting part of. All right. So this term, our end of term project, is a collaboration
with SpaceX.
with the art class, with Miss Hetland's art class. Okay?
Yeah, so we're creating, wait, so we're creating an environment for them to draw, or like a rocket thing to draw?
So here's what we're going to be looking at. Okay? You are going to be researching. You're going to be researching how to colonize a body in our solar system. And then you are going to be supplying that research to the art program of Miss Hetland's class, and they are going to make a piece of art based on your research.
So we can't draw it, we just have to do it.
You can give them some preliminary drawings, some ideas of what you think, what you would like to see out of it. But the fact of the matter is that they are the artist. So they're going to be making the art as a part of a. So we're doing a collaboration with the art program because this is Da Vinci Academy of Science and the Arts. This is one of my very favorite things in all of the world. Combinations of art and science. Okay?
So can we give them like pointers on how it should look?
It's just a grocery list.
So here's what we're going to be looking at. The posters that we have hanging in the science hallway. This is the inspiration for what we're going to be doing for our end of term project.
Oh, no.
You are going to be doing the research of the science of colonizing another planet or moon in our solar system. Supplying that research to the artists. Michael, I told you to stop playing for
It's just too fun.
It's very fun. You're going to be supplying what you know and what you research to them. This is going to be the end of term project for this class. We need to get it to the art peeps to start off next term so they can make some art out of it. Not everyone's research project will be selected. Only the best will be selected by me. Only the best will be selected by me as worthy of an art project. Okay? Not because I dislike you, not completely because I dislike you at least, but because I know that some of the research will be really, really well done and make it possible for a good art project. And some of the research will be fine, but may not lead to a good art project. Okay? So what we're working on this week is you're going to be making a destination report. Okay? So before we learn how to colonize one of the planetary bodies in our solar system, and when I say planetary body, I mean something that is a planet or a moon or a dwarf planet.
Not a gas giant.
Okay, well, no, a gas giant does count as a planetary body, but a planetary body is a more inclusive category. You know what I'm saying? It includes moon, dwarf planet, planet, other large things, okay? So when we talk about a planetary body in the solar system, this is part of the reason why I want to make astronomy a prerequisite for this class.
So we know about
So you know about them, but we're going to do a quick crash course on the planetary bodies in our solar system.
them. So can we use like exoplanets as well, which is
Exoplanets, we're going to just focus on stuff in the solar system. Okay? Spoiler alert, you don't get to choose Mars.
Oh,
You don't get to choose Mars because I get to do Mars. Okay? Because, yeah.
I'm the boss.
Because I'm the boss, yeah. And because I'm not gonna, I don't want to make it sound like this, but Mars is the easiest one.
True. So you already have so much research.
Okay, there's already a lot of research. It's not going to require a whole bunch of creativity on your part. The other planetary bodies in the solar system are going to take some creativity on your part. Okay? So, let us take some notes on some bodies in the solar system. Yes, sir, Repeat.
do you think that I have enough, that there is enough information about the planet to deal
Haumea. We don't know what Haumea is really made out of. We don't know a lot about it.
We don't like Kevlar, the one where like on one side it's always hot, on the other side it's always
Kepler.
Kepler.
So we're not doing exoplanets. We're all, what? Yeah. So if we don't know a certain thing about your planetary body, then you'll need to find the best research possible on it and make a prediction based on that research.
Why can't we do Kepler?
We can't do any exoplanets because I want you to focus on stuff in our solar system. Okay? Primarily because getting to exoplanets right now in any decent amount of time is impossible with current technology.
Until you imagine the technology.
Okay, until we make the technology. So, in the solar system, let's talk about it. All right? So what do we know about the solar system?
It's a system.
It's a system of
planetary bodies.
has
gas
planetary
giants,
bottoms, gas giants, moons.
planets. It houses our planet, Earth.
Yes.
It has this giant sun. The sun is green. We have Venus, Mercury, Mars, Saturn, Jupiter.
Yeah.
I do it on
We made a-
Okay,
a
so
movie title based off of the lunar system.
in our solar system, we have 8 planets, 7 of which are not Earth. Okay? Surprise, surprise, you don't get to choose Earth for this project. Trent just picks Earth, gives descriptions on how to build a house.
No, we get Earth and we give descriptions on how to fix climate change.
Yeah, there you go. How to fix climate change.
Can we do the sun?
Can you do the sun? No. Because the technology required to colonize close to the sun is nowhere near being developed yet.
You just make Dyson sphere and live on the Dyson.
We could do a Dyson swarm, yeah. Okay.
I heard that we can actually like do a Dyson sphere with our current technology.
Dyson
But we
swarm,
don't have
Dyson.
the material.
Yeah, we could do a Dyson swarm, but anyway. So we have 8 planets in our solar system. We'll start close to the sun. You can choose Pluto. Yeah. So I will give you the list of things that you can choose from. That list includes includes all the planets except for Earth, most large moons, and a few dwarf planets. Except for Mars. Yeah, because I get to do Mars.
Can we try doing it? What are they called again? Never mind.
Very good. You can also choose to do a non-planetary colonization, which would be interplanetary space. So like an Allen cylinder, which we will talk about later. An Allen cylinder? Is that the name? I forget the name.
Isn't that?
Okay, let's just talk about it, okay? I know that you're all curious about specific cases. Let's talk about the individual planetary bodies. Mercury, closest planet to the sun. Couple of things about Mercury that you will need to solve. A couple of problems that you'll need to solve looking at Mercury and colonization of Mercury. There is no atmosphere. It also spins very slowly. So the sun's facing side is extremely hot. Because it has no atmosphere, the non-sun facing or the leeward side is extremely cold. And it is that way for a long time because it rotates very slowly. It is mostly made out of metal with a little bit of rock. There's not a lot of dirt. There's dirt, there's rock and so forth, but it's mostly like a powder. You'll do all this research later. I have some ideas that I think are pretty cool on how to colonize Mercury. If you want to choose Mercury and want to get my opinion on specific ideas, I could give you some starting points. I'm going to just give you 2 words. Walking cities.
Walking cities.
Oh, and it follows the center.
Why don't give the imagination? Because I'd love to fill out my notes in terms of what I do.
Okay, walking
People living on Neptune.
walking cities. We're talking about cities that stay on the terminator, which is the line between night and day. Okay? And just the idea of naming it Terminator City would be kind of a cool idea. Okay? All right. So, yeah, conveyor belt. It would be easier probably just to use a city that has legs.
Well, no, what I would do is just go underground.
Okay. There you go. All right. So, Venus.
I deal with my view.
Venus. Venus. Couple of problems with Venus. It has an unbelievably thick atmosphere. And the majority of that atmosphere is carbon dioxide.
Plants, just throw trees at it.
Throw trees at it. There will be a terraforming portion of this assignment. But yeah, anyway. It spins very slowly once again. In fact, it spins very slower than any other planet in the solar system. Okay, it has a surface temperature around the entire planet because of its thick atmosphere. Around the entire planet has a surface temperature that's hot enough to melt the metal lead.
So should we stay above the atmosphere?
I know.
So on the surface, it's extremely, extremely hot. Up in the clouds, it's not so hot.
What I'm saying is, I understand that like most of the atmosphere is blocked off with sun heat.
It does reflect a lot. It has a very high albedo. It reflects a lot. But because it's primarily carbon dioxide, and carbon dioxide is a greenhouse gas, the heat that does get absorbed in the planet stays there. Okay? It has no moons. It has, as far as we know, no like water. Not even in clouds. It has a little bit of water. Well, it has a little bit of water in the atmosphere, just a touch. Most of that water has been boiled off, though, because of the heat.
Have you landed anything on it?
We have landed some things on Venus. Yes, the Venera probes from the Soviet Union. The surface.
Can we see pictures?
Yes, the surface of Venus looks cool. But not,
Doesn't feel cool.
it definitely doesn't feel cool.
Living on the surface, bad idea. What's the third?
Living on the surface is probably impossible with modern technology. I know how to solve our problem, ice cubes. Okay.
Or like a little spray bottle.
What would be the consequence from bringing a temperature that usually, I know, planets that's usually that hot down to like
Okay.
average?
This is what Venus looks like. Oh my gosh. Come on, computer.
Is it even a computer or is it really that laptop?
The atmosphere is yellow. The reason why it's yellow is because of sulfuric acid.
This is the planet where it like
Rains acid.
Yes.
Yes. But the rain doesn't actually reach the surface because it evaporates before it gets to the surface.
How long was it for a while?
Yes, acid clouds. Whoop, whoop.
So that's the consequence. If you bring down the temperature of the planet, the rain, the acid rain will reach the surface.
The atmosphere? No. It has
It's like the acid that rains, is that pure acid?
sulfuric acid, yeah.
What is the surface multiplication?
So here's another image taken from one of the probes that landed. Okay. These probes lasted only a few minutes before critical components started to fail because of heat. Okay. So we're gonna skip Earth and Mars because Earth is too easy.
How fast does Earth spin compared to the?
Very fast. So the day on Venus is equal a Venusian day is 5,400 hours. It takes 5,400 hours for the planet to rotate once. That is 225 Earth days.
That's a year. Wait, no.
It's actually longer than a Venusian year. It takes less time for Venus to go around the sun than it does for the planet to rotate once.
Oh my.
And not only is it rotating really slowly, it's also rotating backwards. It doesn't rotate west to east, it rotates east to west.
Does it matter?
Does it matter? Not really. But the fact that it rotates super slowly is a problem. Okay, so that's Venus. We're going to skip Earth and Mars to talk about Ceres. Go for it.
That means it's mostly day on one side, but almost ever.
Yep. It's day for 100.
So does Ceres have water on it.
Here is Ceres.
Every time you want to go to sleep, you have to travel to the other side of the world.
Ceres is one of the asteroids in the asteroid belt. It is the queen of the asteroid belt. It is considered a dwarf planet. It is the nearest dwarf planet to us. It's the largest body in the asteroid belt.
Why is this guy special?
Didn't Ceres used to be a planet? Like they
Ceres used to be considered a planet, yes.
like Pluto?
Ceres, also, by the way, Ceres, the Roman god of grain, that's where you get, who had some Cheerios or some Frosted Flakes this morning, or some Lucky Charms? Cereals are named after Ceres.
Who eats breakfast?
Who eats breakfast? Okay, so this is Ceres. Once again, no atmosphere. Also, big problem, really low surface gravity. We're talking less than a tenth of Earth's surface gravity.
So you can jump off the planet.
You cannot jump off of the planet. No, not that low. But it is very small. Also, collisions with other asteroids, kind of a problem. Okay, not and micro asteroids as well.
Is it possible to move this guy out of the belt?
Is it possible? Yes. Is it practical? Absolutely not. Moving something this large in its orbit would be extraordinarily difficult, and you wouldn't really have anywhere to go, because this is the only place in the area that is like a stable orbit. If you go inward, you get close to Mars, and Mars screws with its orbit. If you go outward, you get any closer to Jupiter, and it screws up Jupiter, and it screws up its orbit even more.
All right, so we just have to install turrets on either side to start destroying our
It's not like it gets hit by a large fellow asteroid every day. The asteroid belt is actually very, very sparse. If you were standing on Ceres, you probably actually wouldn't be able to see any other asteroids. But
Why don't we just move the planet and
to blow up Mars, that's not a great idea. Okay, so that's Ceres. Yeah, lots of interesting things. There is water, ice on Ceres, which would be useful. But yeah, pretty interesting. Jupiter. Everybody knows Jupiter, largest planet in the solar system. Let's see here. It has many moons. We can talk about different moons that it has, but yes, it does have an ocean moon named Europa, which we will talk about. Jupiter, couple of problems with Jupiter. Radiation, because Jupiter has an extremely strong magnetic field. Getting through its magnetic field could potentially kill you. The whole problem that there's not a surface. Well, not really. Not one that you'd think of as a surface.
Wait, there's actually, wait, what?
By the time you get to an area that is dense enough to be solid-like, it's so hot and so high pressure. So under a few thousand kilometers of atmosphere on Jupiter. Jupiter is primarily made out of hydrogen. Hydrogen starts behaving like a metal.
So you'd be walking on like liquid.
You wouldn't be walking anywhere, buddy. You would be crushed instantly by the atmospheric pressure. But it's not like it's atmosphere and then solid surface. It's atmosphere, super liquid, then a super fluid, and then metallic-ish hydrogen, and then at the very, very center is probably something that you would consider solid. But by the time you get there, the heat, pressure, I mean, the pressure becomes so intense that the gases start acting like liquids. Yeah, it's kind of like the plasma, yeah. It gets absurd. Like the physical properties of the interior of Jupiter are just stupid. They're mind-blowing. Okay? The only way that we'd be able to colonize Jupiter at all would probably be something like the Cloud City on Bespin in Empire Strikes Back.
What if we just steal its core? And then
Steal its core. How are you going to do this? Gesundheit.
We throw like rocks into it.
Just throw a whole bunch of rocks. Not a great idea. What?
I think if we steal the core, it'll make
Okay.
a magnetic field, and then everything will go away.
Europa. Europa, the moon of Jupiter.
They made a game about this, about you have a submarine in Europa, and you're like fighting aliens in there.
So Europa is a moon of Jupiter that has more water than all of the oceans of Earth combined. Problem here, it's under several kilometers of ice.
Not only that, but there's a bunch of sea monsters.
We don't know about the monsters.
No, we do. It's not okay.
Also, by the time you get to that water, it's obviously pitch black, very cold. Under several more kilometers of liquid water, you get to an active geologic surface. So there's a whole bunch of underwater volcanoes, very similar to what we have here at the mid-ocean ridges on Earth. Okay. We don't know a lot about what's going on underneath the ice on Europa. There is a mission that is going to be sent to Europa called Europa Clipper, that is going to orbit Europa and possibly have a lander, but I find that extremely unlikely.
Well, couldn't we just make like a tiny robot thing that could just drill into it for a couple of years?
So it would take a while to drill that far, number one, and it would also take an enormous amount of energy. And this far away from the sun, solar energy is not really an option. So nuclear is really the only way you could do that, and the amount of energy that you would need to drill through this ice would dictate that you have a relatively large nuclear reactor.
That sucks, man, because we can actually poison this planet before we can get there.
Would what? Bombing it would be like a mosquito trying to bite a blue whale.
But what if we bombed it a couple times?
If you bombed it a whole bunch of times.
Yeah,
Remember these. Shush. Even though this is a relatively small planetary body, you have to remember that our technology is tiny in comparison. Yes, Aiden. Is there the possibility of life on it? Sure. Is there evidence of life on it? No. Not yet.
I mean, we can't find any of it because it's all so hard.
Because it's all under the ice. Okay? So, Europa. Now, Europa is pretty cool. Let's look at one other planetary body that orbits Jupiter.
Europa actually seems like the perfect place for life.
That is Io.
With the active geological
I should have been taking notes on this.
This is Io. And you might be thinking, why do all of these look different? Well, because Io's surface is always changing.
This is Jupiter, right?
This is a moon. This is the closest moon to Jupiter. Jupiter is trying to rip it apart all the time. This is the most tectonically and geologically active body in the solar system. It has each one of these spots that you see here are gigantic volcanoes.
That's a volcano big enough to see from space are pretty damn crazy.
Okay, it looks like it's covered in pimples because that's exactly what it is.
It's our system's more pubescent planet, right?
Yep, this is the pubescent. Okay, all of the volcanoes have names. You can see here this is a huge magma field. Okay, Io is super fascinating. What is fascinating about Io is you could make a huge amount of energy using geothermal energy. Here on Earth, the country of Iceland produces about 70% of their energy use by just drilling pipes down into their volcanic mountain island, which Iceland is, heating water in those pipes and by just letting the magma underneath their island heat the water and boil it, and then they use the steam that comes out the other end to turn the turbine. Io would be a very, very good place to generate a crap ton of energy.
Basic battery.
Without pollution.
Well, yeah, pollution is essentially an Earth problem because there's no fossil fuels on any other planet. Because there was never any living things to make fossils on any other planet. Yes, Samuel?
Could that, like, if we use like a ton of energy on it,
Uh-huh.
could we like cool down like the magma underneath?
No.
Okay.
This planetary body, this moon, has such a hot core because it's constantly being pulled on by the gigantic gravity of Jupiter. It's being squished. The tidal forces, so like here on Earth, we experience tides because of the moon and the sun, right? And that makes a bubble, essentially, of gravitational energy that goes around the planet following the moon and sun, right? On this planetary body, again, it's not a planet, it's a moon, but whatever. On this planetary body, the gravity is so intense that it stretches and squishes the core and heats it. It's essentially like Jupiter's stress ball. That Jupiter is constantly like squeezing the crap out of it, and the friction in the core becomes so intense that it melts everything inside it. Io is Jupiter's stress ball. And Jupiter has a lot to be angry about, apparently. Yeah.
If we were to set up civilization there, how fast would it take for a volcano to form in front of our eyes? Like, can we actually see them on being formed? Or?
Oh yeah, you'd be able to see new eruptions all the time on Io. Okay, next planetary body. Oh well, let's talk about Saturn first.
Saturn only has slightly more gravity than Earth.
That is true. Yep, in the upper atmosphere of Saturn, there's only slightly more gravity than Earth. That's because it is extremely not dense. It's extremely dispersed.
Well,
If I had a swimming pool the size of a planet, you could put Saturn in that swimming pool and Saturn would float. It is less dense than water. Saturn, a couple problems with Saturn. Again, no surface, at least not what we would consider a surface. Primarily made out of hydrogen, some methane as well.
So far, how much?
Has a lot of orbital debris in the form of the rings. Okay, Jupiter is an interesting place. It would be difficult to make a colony on it, but again, a cloud city would not be impossible. Because the clouds become so dense at a certain level, you would essentially be able to make like a boat kind of a thing, like a very large boat in the sky. Okay.
Flying pirates.
Space.
However,
Space pirates.
I believe that Saturn, the Saturnian system, has two better candidates. They are Titan. Teen Titans. Why are you heading train? Why just to keep yourself awake? Okay, Titan. Here's what's fascinating about Titan. All right,
Is it a Saturn moon?
it is one of the. It is the largest moon of Saturn. It has
Wi-Fi.
a thick atmosphere that is primarily made out of nitrogen, just like ours.
So we just put some air in there.
Is primarily made out of hydrogen. It also has a liquid cycle. Just like here on Earth, we have the water cycle. There is a liquid cycle on Titan.
We just don't know what liquid it is.
Oh, we know what liquid it is, but you're not going to like it.
Acid.
It's methane.
Cool. Gas.
Okay?
Cars. Everyday.
Yeah, except there's no oxygen.
Bruh.
Fine.
Okay? So which is actually a good thing. If you brought an oxygen tank to Titan, that's essentially the same as having a methane tank here on Earth. Okay? But instead of a Delta class fire, but instead of a methane fire burning in an oxygen atmosphere like we have here on Earth, you'd have an oxygen fire burning in a methane-rich environment on Titan. Okay?
Could you just destroy the atmosphere then if you like ignite it?
If you had enough oxygen, but you don't have enough oxygen. Okay, Titan.
Are pretty good.
Here's the thing about Titan. It does have lakes.
What the heck, man?
Lakes of
It's like temptation.
It has lakes of liquid methane.
Oh, so stop. Wait,
What would it be like swimming in there?
it's errors in the code.
And we have
It has to be methane, water.
we have images
Imagine.
of the surface. This is an image of the surface of Titan. This mountain is not made out of rock. It is made out of water ice.
Why is it yellow?
The atmosphere is yellow because of the nitrogen and methane. Yes, repeat. Does it snow? Yes. It snows on Titan. It snows in the higher latitudes on Titan. It snows at the higher elevations on Titan. However, the snow falls very, very slowly. Okay? The rain also falls very, very slowly. The reason why that is because it has much lower gravity than Earth, and the atmosphere is much thicker than the Earth's. So the terminal velocity of snow is something like 0.2 meters per second. So we're talking about a descent of 20 centimeters in 1 second, which is about that far. Very, very slow.
That's not bad.
That's pretty dumb.
0.2. Oh wait, for snow, that's true. For rain, excuse me. Imagine rain falling that slowly. Like being able to track an individual raindrop falling to the ground.
How fast the snowball?
I don't know, slower than that. But the snow doesn't look anything like snow here on Earth. It's yellow, yes, because that's the color of solid methane. And it doesn't make six-sided flakes like we have here on Earth.
How do we know how they look like that?
Solid methane
Oh, we tried making
crystal.
methane snow.
Oh, we can make methane snow.
No, do we have methane snow here?
You can make it. It just has to be unbelievably cold.
Has there ever been like methane snow?
So methane makes this is the basic shape of solid methane. It's pentagonal. So
That's pretty damn.
on Earth we have six-sided snowflakes. On Titan you would have five-sided 3D pentagons.
That's sick, man. That's
So you'd get snowflakes that look like that.
exactly like that.
Okay?
And you could watch it slowly.
And you could watch it slowly descend.
What about on your fingers?
Would it melt on your finger? Yes. And you better hope that your finger is not exposed, because your finger would instantly freeze and then fall off. Is it skiable? I have no idea what the physical properties of methane snow would be in terms of skiing.
Your ski catch fire.
Can we just talk about this URL as well? TCDBBUR0R8X Abyss. Okay. Now, also, fun fact,
That's fine.
with a wingsuit, you could fly under your own power on Titan. Under your own power.
Fly. We can fly.
Wingsuit, jump off cliff, flap wings. You are now flying. Okay? You would be able to fly under your own power. I'm not talking gliding like we do here on Earth. I'm talking you would be able to fly on Titan. The reason why that is because it has a thick atmosphere and it has low gravity. So human muscles would be able to generate enough thrust and lift to make you fly on
When
Titan.
you leave the atmosphere, could you enter space on the
Absolutely not. You would not be able to leave the atmosphere, because the higher you get, the thinner the atmosphere becomes.
It'd be great to make a civilization that's like you just fly.
Okay, now let's go to the other cool moon of Saturn. This is Enceladus.
That's perfect.
Some people say Enceladus.
That has to be an alien world. You see those lines and everything?
But those are called the tiger stripes. Chavez Philip.
Yeah.
What's
And
up?
How small does something have to be in order for you to jump off of its gravitational pull?
Something like a very small asteroid or comet.
Um,
Okay, Samuel.
on Titan, if you jump from a cliff, would you live?
Your terminal velocity would be low enough to where you would probably live. You probably would not enjoy the landing, however. Probably break some bones. I think that I don't know what the terminal velocity of a human being on Titan would be.
Dude, I just can't get over the fact that you can make like a really cool wingsuit and take off on your own.
Yeah,
You can be birds, you want.
we could be birds. Okay, this is Enceladus, and yes, this is a real image. Enceladus is Europa 2.0, this time colder.
That's a little.
Okay?
So really,
Europa is very cold, but Enceladus is similar to Europa in that it is covered in frozen water ice. However, unlike Europa, Enceladus does not have a global ocean underneath. It has only pockets of liquid water underneath. Enceladus is also very small.
so no atmosphere.
Yeah, no atmosphere. It's very, very small. It has geysers of liquid water that shoot out of certain places. Right here, you see these blue cracks. These are the origin of geysers that shoot out into space from the surface of Enceladus.
That's it.
that shoot all the way to space?
Yes, these geysers have enough velocity to actually launch crystals of water ice into orbit around Saturn.
Now we're playing yes or no.
Okay?
Scenario game. If you were to have a suit that was pretty well armored, could you lay on this site and just launch?
Get launched, yes. You could use the geysers on Enceladus to launch things into orbit because the gravity is so small. So yes, you could put like a cube of something on the geyser and it would shoot out and it would generate enough thrust. Aiden.
Make a rocket launches on that, that'd be crazy. Just stick in the geyser.
Yep, stick it in the geyser. Okay, we're running out of time. All right.
How much of a problem it would be for like kids to push their friend into a geyser and constantly lots of whole
All right, Uranus.
Exactly. Yeah, bullying on this planet would be pretty bad.
Uranus is pretty boring, but we could colonize it. Whoever has this on here, they are wrong. This is not Uranus. That is Neptune. So get your planets straight. Uranus, or if you want to say it the correct way, Uranus. Uranus. Henry. Why do we call it King Henry?
Because that was the original name they were going to choose.
Yep.
Was Henry.
Yep. Because that was the anyway.
And that's way cooler.
I would vehemently disagree that it is cooler, but
It just be
this is Uranus, and yes, this is a real image. It looks like a blue powder. It looks, let's be honest, this looks like a bath bomb that your mom bought from Bed Bath & Beyond, and it's like infused with
Can we just
CBD oil and like echinacea or something like that. Yeah, it is.
It looks like someone just cracked a spear and like your
Yeah, it really does. It looks like a Blender rendering that's like really low quality. It looks like you could just go and like pet it. It almost looks like a piece of chalk.
Why are we dishing on this planet, man? It has feelings.
Okay, it is very cool. I wouldn't say that it's all that interesting for colonization, but if you choose Uranus,
So does it have an atmosphere?
oh yes, it is all atmosphere.
Wait.
Uranus is what is called a gas or ice giant. It's really cold. Yeah. Moving on.
So could you make a continent out of frozen water?
Neptune.
Okay.
The water.
It's a okay.
This is Neptune. Couple problems with Neptune. It's cold. It's really far away. It has 1,200 km/h winds. It also has shards of tiny diamonds in those winds.
Oh, yeah, if it gets shredded.
So on this planet, if you got caught in a storm, it would shred things using tiny little shards of diamonds that are flying at 1,200 kilometers an hour. More like, let me think here, more like 600 miles an hour. 700, something like that, yeah. Okay.
The economy on this planet would be massive.
The diamonds.
Yeah.
We're not talking about big diamonds, we're talking like
Micro.
tiny little diamonds flying really fast.
So
Imagine,
they, like,
imagine dying from someone using a pin and just poking you a bunch of times.
So wait, would they go straight through you?
Oh yeah.
It's 700.
But
miles per hour.
the wind itself would probably tear your limbs off anyway. So.
A car. Imagine travel.
It is possible that we could build some sort of like high altitude colonization on Neptune. Here's what's interesting. Here's the interesting Neptunian system. Body. This is Triton.
Wait, what? Is it actually like a half?
It is not a half. It's just in darkness. We only have one image of it, or one like good image of it. Triton. Oh wait, that's Titan. Yes, don't get Titan and Triton mixed up. This is Triton. Problems on Triton. It's cold, but there is a lot of water ice. It'd be a pretty cool place to visit. Low gravity, once again. Lots of resources, but it's cold. The sun is extremely faint and small. But it'd be cool. Elijah. Not all of them.
Did you say
Uranus has 82-year-long seasons.
Did you say faint atmosphere?
Faint sun. No, there's no atmosphere on Triton. Okay, I'll see you on Wednesday. We'll start working on some research on these different bodies. Bye, bye, bye.